Alright, so to connect Young's modulus to the inner atomic spring constant, we start off with the original equation of Young's modulus, which is stress over strain, and we're going to break down each part. So we know that stress is equal to the force total over the area of a cross-sectional, and the strain is equal to delta L over L. Delta L is the amount that something is stretched or compressed, and the L on the bottom is the original length. Alright, so first we're going to get our formula from strain, and what we're going to look at here is this little cube right here is the atomic level of a pure metal, and we're looking at that because we're going to see that the length of each atom, each block is representative of an atom in this pure metal, and each block is going to have a length of d, and there's also interatomic forces acting between the atoms, and each of those forces is working at the length of d also, because it's the radius of one atom and the radius of the next one, and 2 times the radius is the diameter, so it's all going to equal d. So we know that we can rewrite the strain formula. So the delta L is just going to be equal to the S, which is the stretch, and we could put instead of L, we know that L is equivalent to D, the diameter of the atom. So S over D is equivalent to delta L over L, which is strain. Shouldn't have wrote that all backwards, but so that's how we get this part for strain. And now for stress, we know that it's the force total over the area. And since we're dealing with spring, we know that the force total is just going to be the force of a spring, which is the spring constant times the stretch. And the area is going to be equal to, so if we're looking at a cube, we know that, well, of a square, it's going to be length times width, since we're taking one little square of it. And since we know that the length is equivalent to the width, and that both are d, that's the same thing as area is equal to d times d, which is d squared. Okay, so now we could rewrite stress as being k times s over d squared. Alright, so now put Young's modulus back. We're going to do stress over strain, so we have k times s over d squared divided by strain, or multiplied by the reciprocal, times d over s. Alright, so this s and this s are going to cancel out. This d and the exponent of this d are going to cancel out, and that leaves us with k over d. And that is Young's modulus for the inner atomic spring constant. And that's how we get it.